Hi folks, today we're going to focus on adding and subtracting with rational exponents. So starting out, just to kind of remind you of what we're doing here, we're basically combining like terms. So 4x minus 1x, if you'll remember all the way back to pre-algebra, would be 3x. And same type of thing here, 6x squared minus 2x squared, they have the exact same variable with the exact same number of exponents, so we can go ahead and combine those, and that would be 4x squared. So now, coming down to dealing with our radicals and our rational exponents, the thought process doesn't really change. We have a 4x to the 10, or 4 root 10 here, and a 4 root 10 here. So it's just a matter of combining our like terms. The coefficient here is 1, so we're really just looking at adding 1 plus 7. So 1 plus 7 is 8, 4th root of 10. Alright, so there it is. That's done. Same type of thing can happen here. Alright, we have both are 8 to the 1/5 power, so they're basically like terms. So we're just going to add the 2 and the 10. So 2 plus 10 would be 12 times 8 to the 1/5 power. And that's done. Now here things are going to get a little more complicated because initially things appear like you can't put them together. If we notice here, we have a 3rd root of 54 minus a 3rd root of 2. They do appear to be different, but notice that the 3rd root of 54 is red, so that means that I want you to keep an eye on it because we can change it. That 3rd root of 54, we can break that apart into 2 different 3rd roots. And this is where that list is going to come back into play. What 2 numbers break apart to give us 54, where one of them is a perfect cube? And in this case, it's going to be 27 and 3. I'm sorry, 27 and 2. Change that to a 2. So now, the 3rd root of 27, that's 3. So we have 3 times the 3rd root of 2 minus the 3rd root of 2. So now we can combine like terms. These are the same. So here, with no coefficient, we can assume 1. So our answer then would be 3 cube root 2 minus 1 cube root 2, which would be 2 cube root 2. And there's our answer. Same type of thing can happen on this next one. 3rd root of 5 doesn't break down, but 3rd root of 40 does. That breaks down into 2 different 3rd roots, where one of them is a perfect cube, which would be 8. So we have the 3rd root of 5 minus 2 cube root 5. I'm sorry, it'd be plus. So now cube root 5 plus 2 cube root 5 is going to wind up being 3 cube root 5. So this next one, they are the same. They're already 5th root of 12, so we can put them together. Very simple. 6 times the 5th root of 12. The next one's going to take a little bit more thinking. First off, they're both 9 to the 2/3 power, which means they're the same. So we can just go ahead and add the 4 and the 8 and get 12 times 9 to the 2/3. But now I'm going to think a little bit about this 9 to the 2/3 power. There's something I can do with that. First off, remember what 9 to the 2/3 means. It means the 3rd root of 9 to the 2nd. Well, you can't really do anything with that 3rd root of 9, but we can do something with the third root of 81. And that we can break apart. The third root of 81 breaks up into the third root of 27 times the third root of 3. So what we actually have here then is 12 times the third root of 27. This part here is just going to be 3 times this part, the third root of 3. So now we can just multiply the 12 and the 3. So it would be 36 third root 3. So sometimes they take a little bit more noticing, a little more thinking about, and see if you can break it down. I don't expect you to notice those things right away. It takes time, it takes practice. Don't get frustrated with it. On this final page, I am going to challenge you a little bit to go ahead and try these first 3 on your own. This first one will be the cube root of 3 as its final answer. The next 2 should be pretty obvious to you. They are the same for both parts, so you can just go ahead and combine the coefficients. The last one, on the other hand, I am going to kind of work on that one a little bit with you, because that one is going to require a little bit more thought. Now, when we're taking a look at that, we can break a lot of this apart. So we have 12 times the third root of 2 times the third root of z to the 5th minus z times the third root of 54 times the third root of z to the 2nd. Now we can go ahead and start breaking some things down. So the 12 doesn't do anything, the third root of 2 doesn't do anything, but right here, this third root of z to the 5th, I can break something out of that. This 3 goes into 5 once, so I can break out a z to the 1st and still have a cube root of z squared left over. Minus z. Now this third root of 54, that can break down into 2 different third roots. And that'll break down into 27 and 2. Let me take this part down here. So I have z, third root of 27 is 3, so z times 3 times the third root of 2 times, now this third root of z squared, nothing happens with that. So if I take this part, combine everything that is outside of the root, so the 12z, everything that is under the root, the cube root of 2z squared, minus, and do the same thing here. So I have 3z times the cube root of 2z squared. You'll notice that I have the same thing there and there. Z times the cube root of 2z squared. So now it's just a matter of putting together the 12 and the 3. So 12 minus 3 is 9. Z cube root 2z squared. And there we have it. It's done. I know this is going to take some getting used to, and it's going to take some frustration, but I do believe that this is something you can do, and don't worry, I can walk through that last problem again in class, so no worries. So let's just work on the assignment, page 424, numbers 32 to 40 all, and 60 to 65 all. Best of luck to you. We'll see you in class.